Hello students, our topic number 29 is interpolation and extrapolation by using Newton's forward differences method. Newton's forward differences method. Now question is given, x value is 5, 10, 15, 20, y value is 10, 17, 29 and 45. Now find value of y if x equals to 7. Find y if x equals to 7. X equals to 7. Now two conditions should be satisfied before applying Newton's forward differences method. First one is independent variable must have equal intervals. Independent variable means x must have equal differences or intervals 5, 10, 15, 20. Differences of 5 is there, 5 means first condition is satisfied. Number 2, interpolated value should be in the beginning of the series. Here we find the value y for x equals to 7 means x equals to 7 lies in the beginning of the series. Therefore second condition is also satisfied. Now we can apply Newton's forward differences method. Now calculate differences 1. 45 minus 29, 16, 29 minus 17, 12, 17 minus 10, 7. For next 16 minus 12, 4, 12 minus 7, 5 means delta not 2. For next 4 minus 5 minus 1 means delta not 3. Now naming the x series and y series. First one is x0, x1, x2, x3, y0, y1, y2, y3. Here delta not 1 starts with delta not 1, then delta 1 1, delta 2 1, then starts with delta not 2, delta not 2, next one is delta 1 2 and delta not 3. Now first calculate value of x. X equals to value of y to be interpolated, value of y to be interpolated minus preceding value, divided by difference between adjoining values, Clear? X is value of y to be interpolated. Value of y to be interpolated is 7. Then preceding value is 5. And difference between adjoining values 5 and 10. Difference is 5, which means x equals to 7 minus 5, 2 divided by 5. 2 divided by 5 equals to 0.4. Therefore x equals to 0.4. Now for Newton's forward differences method, take first values of each column. Take first value of each column. Clear? Multiply 10 by x second by x by 1, third by multiply 10 by x. Now we are formulating the formula. Right over here x first term, then x by 1. Write 1 over here. Write 1 over here. 1. Then write x by 1 over here. X by 1. Then third term. Write x into x minus 1 by 2 factorial over here. ठीक है, x into x minus 1 by 2 factorial. Then for last term x minus 1, x minus 2 by 3 factorial. This is the way to formulating the Newton's forward differences method formula. Write 1 over here. For second term write x by 1 means 1 factorial. For third term x into x minus 1 by 2 factorial. For next term x into x minus 1, x minus 2 by 3 factorial. Now formula is y7. We have to interpolate the value of x equals to 7. First term write 10 plus, first write general formula, write y naught plus x into delta 1 naught, x into delta 1 naught. Second x into x minus 1 over 2 factorial into delta 2 naught plus x into x minus 1 over 2 factorial into delta 2 naught. Third x into x minus 1, x minus 2, 3 factorial into delta 3 naught plus x minus 1, x minus 2 over 3 factorial into delta naught 3. This is our formula to find the missing value for Newton's forward differences method. Now by putting the values of y naught, delta naught 1, delta naught 2 and delta naught 3 and value of x, we get y7 equals to 10. Y naught is 10 plus x is 0.04. X is 0.04. Right? 0.4 into 7. Delta naught 1 is 7 plus x is 0.4. 0.4 then 0.4 minus 1. Delta naught 2 is 5 into 5 divided by 2 factorial means 2 into 1 plus x is 0.4 then 0.4 minus 1, another one is 0.4 minus 2 over 3 factorial means 3 into 2 into 1, delta naught 3 is minus 1, therefore multiplied it by minus 1, which implies 10, 0.4 into 7, 2.8. Then by solving this we get minus 1.2 over 2 plus minus 0.384 divided by 6, 3 into 2, 6, which implies 10 plus 2.8 minus 0.6, 1.2 divided by 2, 0.6 minus 0.0064 by 0.384 divided by 6 is 0.064, which implies y7 equals to 12.136. So our value for x equals to 7 is 12.136. For value for x equals to 7 is 12.136. Answer is 12.136, which is by using Newton's forward differences method. This is interpolation formula because x equals to 7 lies within the limits, within the series. Therefore, this formula can be used for interpolating the values. Newton's forward differences method. Interpolated value should be in the beginning of the series. So our answer is y7 is 12.136. Clear? Interpolated value should be in the beginning of the series. To find the value beginning of the series, in the beginning of the series, we can use Newton's forward differences method, which is case number 1. Now we will do case number 2. Case number 2 is Newton's backward differences method. Backward. First one was forward differences method. This one is backward differences method. Again, write same question. X and y is given 5, 10, 15, 20, 10, 17, 29, 45. Clear? Independent variable must have equal intervals. Clear? 5, 10, 15, 20 have equal intervals. This method can be used in under two conditions. Condition number 1 and condition number 2. Used for interpolating near the end of the series. If you want to interpolate near the end of the series, you can use this formula, Newton's backward differences method, or used for extrapolating. Important point, used for extrapolating values little ahead of the series, means little ahead of the series, like find y if x equals to 22. X equals to 22. Now 22, we have to find y for x equals to 22. Now 22 lies outside the series, means this method is belongs to extrapolation. Newton's backward differences method can be used for extrapolating values little ahead of the series. 22 is little ahead of the 20. Therefore, we can use Newton's backward differences method. First case was Newton's forward differences method for interpolating the value. This method is for extrapolating the values. This is extrapolation case. To find differences, same 16, 12, 7, same 4, 5, minus 1. Difference is 1, difference is 2, difference is 3. So name it as y0, y1 same as previous question, y3, delta naught 1, delta 1 1, delta 2 1, delta 2 naught, delta 2 1, delta 3 naught. Now find x. Formula for x is same as previous question, Newton's forward differences method. Value of y to be interpolated is 22 minus preceding value. Preceding value here is 20 divided by differences between the two adjoining items. Here differences of the intervals 5, which is equals to 2 by 5 equals to 0.4. Therefore, small x equals to 0.4. 5 is differences between the intervals of independent variable. 5, 10, 15, 20. Difference is 5. 22 is value to be interpolated, 22 minus preceding value 20 Preceding value of 22 is 20. Therefore, x equals to 0.4. Now, for backward differences method, take last terms. Right? Therefore, formula is y22 equals to y3 first term plus x delta 2 1 by 1 factorial plus this one x plus 1 delta 1 2 by 2 factorial plus x plus 1 x plus 2 by 3 factorial delta 0 3. Clear? In previous question, here it was x minus 1. Now x plus 1. X into x plus 1, x into x plus 1, x plus 2. Right? y3 over here, delta 2 1, delta 1 2, and delta naught 3. This is the formulation for Newton's backward differences method formula. Now, by putting all these values, we get 45, y3 is 45 plus x is 0.4. 0.4 into 16 over 1 plus x is 0.4, 0.4 plus 1, delta 1 2 is 4 into 4 over 2 into 1 plus x is 0.4, 0.4 plus 1, 0.4 plus 2 over 3 factorial means 3 into 2 into 1. Delta naught 3 is minus 1. Multiplied it by minus 1. Now by calculating all this, we get 45 plus 6.4 plus 1.2 minus 0.224 because minus 1 is there, which is equals to 52.26. y22 is 52.26. This is a case of when we want to find y for x equals to 22. For x equals to 22, y is 52.26. As x lies outside the given series, therefore this is a special case of extrapolating, because this method is used for extrapolating values little ahead of the series. This is a special case of extrapolation. Case number 1 was case for interpolation. Case number 2 is for extrapolation. Case number 1 was Newton's forward differences method. This case is Newton's backward differences method. Newton's forward differences method is used for interpolating the values in the beginning of the series, and Newton's backward differences method is used for interpolating the value in the end of the series, and number 2 used for extrapolating values little ahead of the series, as x22 lies near to the end of the series, near to 20. Therefore, we are using Newton's backward differences method for extrapolating the values. Our answer is y22 is 52.26. Formula is first term is y3, another use delta 2 dash, means always use last values of the column for backward method, first values of the column for forward method. First one is y3, second delta 2 1, third one is delta 2 1, again delta 2 1, means delta base 1 part 2, delta base 2 part 1, delta base 0 part 3, and third is delta not 3. In previous question, here x minus 1. Now here it is x plus 1, x plus 1, x plus 2.